Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video, we're going to have a look at how to test alternator diodes. Alternator diodes, they come in different shape and style, but their function is the same. Now when alternators are generating electricity, alternating current is produced on the stator winding, and that alternating current, it has to be converted to DC current. So that is the duty of the rectifier diodes. They rectify. Rectification is the process of converting an alternating current into a direct current, because battery is to be charged with a DC current and all electrical loads are going to be operated by a direct current. Now in order to do that, the alternator have diodes, set of diodes that are used to rectify. For example, this right here is a rectifier assembly. As you can see on the rectifier assembly, there are heatsink. This right here, what you see, the majority of the part is a heatsink. And right here we have the battery positive terminal. This is going to be the B+, which comes out of the alternator. And coils from the stator winding are to be connected right here. This is a connection for alternator stator output leads. As you can see, 3 wires are coming out and they get connected to the rectifier assembly. It is a 3-phase from the stator winding. Then when it comes out, however, it is only battery positive, and this right here is going to be negative. So only plus and battery negative is to be taken out. But when it comes into the rectifier, as you can see, it is a 3-phase alternating current coming out of the stator. In order to rectify that, we have diodes. Now if you watch closely, you can see the diodes. Right here there is a diode, for example. This is a diode, this is a diode. Now when this diode is connected in such a fashion, one leg of the diode is connected right here to this metal, and the other head of the diode is connected to this heatsink. As you can see right here, these are where diodes are embedded. If you flip it, you see one leg is right here and the other is embedded into the heatsink. Look, for example, right here, this is how they are connected. This is one leg of the diode, and the head is to be embedded into the heatsink. You know, these semiconductors, diodes are semiconductors that can malfunction if they run extremely hot. In order to dissipate heat, diodes are usually installed on a heatsink. The heatsink profile it comes in different shape. Look at this heatsink, for example. Usually installed on aluminum. Right here we have the diodes. As you can see, one side of the diode is to be embedded on a heatsink. The shape and the method of construction might vary, but their principle of operation is the same. See, heads of diodes embedded in here. As you can see, there are sets of diodes. One set of diode on the other side, other set of diode on this side. One will be the positive heatsink, the other will be the negative heatsink, and terminals are connected here. Terminals to be where the coils of the stator are to be joined right here. This is another form of heatsink. So the heatsink might appear different, but the method of testing and the method of construction and the principle of operation is always the same. In order to test individual diodes, you should be connecting one end of the diode and the other end of the diode to a multimeter. For this test, place your multimeter on the diode function. Right here there is a diode test function. Place it on diode. Now diodes, they allow electricity to pass in one direction only. As you can see from the symbol representing a diode, the white one, see, electricity will be allowed to flow in this direction, in direction of the arrow, but it is prevented in the reverse direction. So that is how diodes are functioning. They allow electricity to pass only in one direction. They prevent when it comes in reverse direction. By doing so, everything that comes out will have only one direction. When diode function is selected, the multimeter has a diode mark right there. There is a diode mark indicating the function is now on diode. Then, once you place it on diode, you can first check the well-being of the multimeter. Now it is reading 0, for example. When you touch, it is reading 0. Now, every diode, it should be reading continuity only in one direction, and it should be reading infinity in the other direction. For this multimeter, if it reads something like this, it is infinity. If it reads something like this, it is a short circuit. If it reads some value, some voltage value, by the way, it is a voltage reading that diodes are tested with. If it reads some voltage value, then the diode is good. Let's go ahead and test this diode, for example. Place one multimeter lead on one end of the diode and the other on the heatsink. Let's place it right here for ease of maintenance. Let's place it right here. Put one multimeter end on this and then place the other. See, it is reading 465. It's a millivolt. Nice. 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 Now when I flip, it should not be reading continuity. No continuity. No continuity. No continuity. As you can see, it has read only in one direction. This indicates all the three diodes are functional. This is very simple test. You test it in one direction, you should have continuity. You flip it, you should be with no continuity. So this is how you can test this is how you can test continuity operation of the diode. And by simply looking at the multimeter terminals that you can use, you can check, you can decide the terminals of the diode. For example, right here, when the positive terminal of the multimeter is touching the positive end of the diode, we have continuity. When the negative end of the multimeter is touching the positive end of the diode, there is no continuity. So from this you can see that these diodes, this is the positive side, but this on the heatsink side is the negative side. This is how you can identify the heatsink even. The negative side is connected here, the positive is connected here. We have continuity, which indicates that this is a positive heatsink. Let's go ahead and do similar test for this rectifier assembly. Now you can start testing the rectifier assembly by simply going to contact this diode ends. But the best alternative is, because the diode ends are connected to the line coming from the stator winding, the best alternative is to place one multimeter end right here. This is the intersection of the diodes. Place one multimeter end right here and then place the other on the heatsink. For this particular line coming from the stator, for example, we have two diodes. One diode is here on the lower heatsink, the other diode is here on the upper heatsink. Let's go ahead and do the test. Place one multimeter end on the stator winding right there, and let's find continuity. See? I have continuity right here. I should not be getting continuity on the other. No continuity. When I flip this, when I place this on the wire line, and this should not be providing continuity, but this should provide continuity. See? Now I have confirmed that both the positive diode and the negative diode are functional. So this line has two functional diodes. Let's go ahead and do the same for the rest. For this line, when you flip, there are two diodes. Right here one diode, and here there is the other diode. Now for this test, let's place one multimeter lead right on the connection of the line and place right here. There is continuity, which is good, and place it right here. There is no continuity. Flip. One should read continuity, the other should not. This should not be reading continuity, which is good, but this should be reading continuity. Okay, you can place it right here. If this is insulated for you, because the heatsink is connected to this terminal, you can place it right here. So, now it is confirming that this diode and this diode are both functional. And for this lead coming from the stator winding, we have two diodes, two set of diodes right here. Let's place one multimeter here. Test, no continuity. Test, there is continuity. Let's flip. Place one here. Test, right here. We have continuity. And when I touch this, there should not be continuity. See? Now we have confirmed that all the 6 diodes on this assembly are functional. So by simply going from this point, this is a central intersection coming from the stator winding, by going from this to every diode heatsink, you can confirm whether the diodes are functional or not. Now it is confirmed that all the 6 diodes are functional. Let's put it aside and do another test. Right here there is a heatsink. The test is the same. We have heatsinks. One end of the diodes is on the heatsink, the other is right here. So you can do the test. One multimeter end right here. Place it here. Let's go ahead and do the test. There is no continuity here. Second diode, no continuity. Third diode, no continuity. Let's flip the multimeter. One multimeter terminal right here. Now because previously there was no continuity, now there should be continuity. See, it is reading continuity, so this diode is functional. Same, right here also continuity, functional diode. And finally, the third is also functional. Let's go ahead, flip and test diodes on this side. Multimeter terminal right here, no continuity. For this one, no continuity. For this one, no continuity. Let's flip the multimeter lead, place the negative on the common line. Now we have continuity. Let's go ahead and do the same for this. We have continuity. We have continuity. So we have determined that all the 6 diodes on this rectifier are also functional. So this is a very simple test. The diode should be conductive in one direction and should not be conductive in the other direction. You can do the same for this also. You see, terminals right here, terminals of the diode coming out from the heatsink. This is a single heatsink. You can check. You can place one multimeter lead right here and place the other on the heatsink. Place it on the heatsink. No continuity. No continuity. No continuity. Let's flip. Place this on any place on the heatsink. Continuity is there. We have continuity. We have continuity. So all the 3 diodes on this heatsink are also functional. Let's check if this diode is functional or not. Very simple. Place one multimeter on the heatsink, the other on the diode. See, it's continuous. Flip it. Clean it. Place one multimeter on the heatsink. Place one multimeter on the heatsink, other on the terminal. Not continuous. Flip it. Continuous. See? So this diode is also functional. There is another diode with a removed terminal right here. Let's go ahead and test that one also. See? It's functional. By simply tapping one end, no continuity in this direction, but when I flip, it reads continuity. This is how you can test. You can do the same. Right here there is a diode, terminal is here. Place one here. Place the alter on the terminal tip. Flip it. This is not functional. See, it's functional. So this is how you can test alternator diodes. Now, when you place the multimeter, if it reads infinity in both directions, it indicates the diode is open. If instead of reading some 400 millivolt or something, if it reads 0, that indicates the diode is shorted out. So this is simply how you can manage a rectifier test. This is how you can perform rectifier test on diodes. So this is basically how you perform a rectifier test. So if the diodes are not functioning properly, your battery will get discharged and alternator will not be properly charging the alternator. So it's a very crucial, especially if someone interchangeably connected battery terminals, accidentally switching the positive and the negative terminals when it is connected to the battery, you more probably have a damage, especially on the negative side of the diodes. Diodes will get burned out. So if you suspect the alternator is not charging properly, or if the voltage is fluctuating, it's a good idea to check the rectifier diode. And you can simply do a rough test. Rough test can be done instead of testing individually. Rough test can be done by placing one multimeter on the positive terminal of the rectifier, which is a B plus terminal, and then place the other on the negative heatsink. It should be continuous in one direction and it should not be continuous in other direction. For example, right this way, it is not functional. But when I flip it, it should be reading somewhere around 800 volt. 800, because we are now reading two diodes in series. It should be reading somewhere around 800. See, it is reading that. This is a rough check. Instead of individually checking, you can also check in such a fashion. This test will pinpoint if there is a short circuit. If there is a shorted diode, you will be expecting some half of this value or zero value. But it will not tell us if there is an open diode, but it will definitely tell us if there is a shorted out diode in the rectifier. You can do the same for this also. Measure between the two heatsink. You should be reading somewhere around 800. See, it is reading somewhere around 900. It is nice. When you flip it, it should not be reading. This is a rough check of the entire heatsink assembly. Well, dear viewers, that is all we have for you in this video regarding how you can check rectifier diodes. If you find this video helpful and if you enjoy what has been presented, please smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.